So in this question here, we've got a curve defined parametrically by x equals 4 sine t and y equals sine of 2t. And t is defined from 0 to 2 pi inclusive. Now what we want to calculate is the parametric integral of this curve. So how are we going to do that? Well, first of all, that would be the area underneath the curve between the x-axis and above, and it'd be minus if it's below. So I'm going to put a sketch at the end of this video so you can see what's going on. But first of all, we need to work out what this integral is. Now a parametric integral is defined as y dx dt dt. That's what we need. So we've got these definitions here. So for that, we've got our y already, and now we need our dx. So let's work out our dx dt. So dx dt, that's just the derivative of x with respect to t. So the derivative of 4 sine t is simply 4 cosine t. So that's pretty cool. Now what we need is this y equals sine 2t. So if I put my 4 cosine t in here, and I've got a sine 2t, that's going to make things a little bit awkward. So I'm just going to show you what I mean by putting those into our integral. So y is sine 2t, dx dt is 4 cosine t. So I'll bring the 4 out the front, 4 cosine t, and then that leaves me with dt, obviously integrate with respect to t. Now if I want to do some substitution, the 2t and the t, that's not going to work for me just yet. But what I do see is the sine 2t, I've got what's called the sum, the two-sum formula. So if I have like this, so sine of a plus b, that equals sine a cosine b plus sine b cosine a. So what I can do is I can turn that into something like this, sorry, turn this into something that's with this. So if I let my a and my b equal t, because obviously if a equals t and b equals t, t plus t obviously is 2t, and that will get me my sine 2t. So then our identity becomes sine 2t becomes sine t cosine t plus sine t cosine t. So that's obviously 2 sine t cosine t. So let's just write that out. 2 sine t cosine t. Now I've got cosine t, so everything's in terms of t as our input to our trig function. So now we've got 2 sine t cosine t cosine t dt. Okay, just tidy this up that little bit more. So 8 sine t cosine squared t dt. So it's always good to tidy these things up and bring as much outside of the integral as we possibly can. So now we've got this, let's just have a look at our parameters. So t goes from 0 to 2 pi. So the range and the upper and lower bound of our integral is from 0 to 2 pi. So that's kind of where we're going to integrate over. Okay, so now how about integrating this? Well, what I want is to substitute something in that when we got our derivative, it cancels something else out. So if I let my u equal cosine t, so if u equals cosine t, that means my du will become sine t in terms of negative sine t, and this sign will disappear. So du equals negative sine t dt. Okay, now let's just plug that into here. So I've got 8. Parameters won't change because we're still in terms of t. So that's fine because I'm going to convert back at the end. So now 0 to 2 pi. I'm going to put the sine t in for now. Cosine squared t, that will give me my u squared. So just times u squared. And then my dt is du over minus sine t. So minus sine t. Okay, so we can see now that these sides cancel out because we don't want the t's in there, obviously, with the u. So now we've got our integral. So let's just put a line down here. So now we've got this minus sign can come out. So let's put a line down here as well. So we've got minus 8, 0 to 2 pi, u squared du. So nice straightforward integral, which is just the power rule. So integrating that, we'll just have raise the power by 1 divided by the new power, multiplied by minus 8. Nice straightforward calculation. So minus 8 u cubed over 3. And that's calculated from 0 to 2 pi. Okay, now what I want to do is I want to convert back into t, so then I can use my 0 and 2 pi correctly in terms of our algebra and our integral. So now I've got minus 8 over 3 u cubed, well, u is cosine t, so I've got cosine cubed t, 0 to 2 pi. Okay, now let's evaluate this. Well, cosine 0, let's just write this here, cosine of 0, that equals 1, and cosine at 2 pi is also 1, so which equals cosine of 2 pi. So let's put the value in for 2 pi. So then I've just got, basically, as that just becomes 1, I've got minus 8 over 3, and then subtract. At 0, it's still 1, so then minus 8 over 3. Then minus 8 over 3 plus 8 over 3, this then just becomes 0. And that's the result of our integral of x equals 4 sine t, y equals sine 2t, from t equals 0 to 2 pi. Okay.